Hi guys, welcome back. In this lecture, I'm going to talk about third order polynomials with complex roots. Okay, so this is the general formula for a cubic function. Px is equals to ax cubed plus bx squared plus cx plus d. Okay, now we need to focus on two parts in this cubic function. One is the d. Let me do it in yellow. D, which is our constant, and our coefficient of the x cube, okay, which is the coefficient. Okay, so let me demonstrate that using an example. Okay, so if I have px is equals to 2x cubed plus x squared, or minus x squared plus 3x plus 6. So our d is equals to 6 and a is equals to 2. Now what a tells you is the is how would the factors going to look like at the end. So for example, what I mean is because you have x to the cube, right, you'll have three factors. Okay, so there will be x plus k, or k can be any number. Okay, let's call it k1, and then x plus k2, and then x plus k3. Now, because a is 2, so somewhere along these factors, I must have a 2 here, right? Because if I go 2x multiplied by x multiplied by x, it will give me back the 2x cubed. Okay, so the function of a tells you how would the factors going to look like, especially the coefficient in front of the x. Okay. Now, what d tells you is because that we're dealing with a cubic function, our first root, the way we found our first root is only by trial and error. Okay, so what is our range of trial and error samples? That is depends on the d. Okay, so the d is 6, right? So we list out every single factors for d. So 1, 2, 3, and 6. Yeah. So let's call these factors potential factors. Okay, potential factors. Potential factors. Now, since we know our potential factors, we need to put in our trial numbers. So let's call these numbers our trial numbers. Trial, spelled it wrong. Trial numbers into either K1, K2, or K3. Okay, so I'll put it in K1 and K2 and K3 because it will give me a whole number, right? So X, let's say for example, if I'm testing, for example, 1, remember it's plus n minus 1, and it's plus n minus 2, plus n minus 3, plus n minus 4. Okay, so if I put in, for example, x equals to positive 1, okay, equals to 0. So my testing parameter will be x equals to negative 1. So let's test that. What we are testing is that what value, let's call this a, that will give me a 0. Okay, so we need to find this a value here. Okay, so for example, px of negative 1, that will give me 2 times negative 1 to the cube minus negative 1 to the square plus 3 to the negative 1 plus 6. So that indeed gives me a 0. Okay, so what that tells me is that at x equals to negative 1 for that function, for px, negative 1 will be my root of my function. Okay, so my factor will be x plus 1, right? X plus 1. So this is a very crucial information because I can use this information to deduce my other two roots, right? So how do we do that? We do that using our long division. So x plus 1 into our long division of 2x cubed minus x squared plus 3x plus 6. Okay, now 2x squared into x plus 1, that will give me 2x cubed plus 2x squared, right? So that will be 2x squared, 2x cubed plus 2x squared. So again, guys, very important. This is everything negative on the inside. So that will be a 0, negative minus a positive 2. So that would be a negative 3x squared. And then I have to drag this column down, which is plus 3x, right? Okay, so what do I have to times this to eliminate this term? Well, that would be multiplied by 3x into x plus 1. So that will be 3x squared minus 3x. So minus 3x minus 3x squared plus, oh, sorry, no, minus 3x. And again, everything is negative. So that will be 0, positive 3, minus a negative 3, that will be a positive 6x plus 6. So again, clearly that will be just a 6. So 6x plus 6 gives me 0. Now, what I've essentially it's doing is I've put in 2x cubed. Let me write down the equation again. Plus 3x plus 6. Okay, so I've factorized out the x plus 1, and then I found that the other factor is 2x cubed, or 2x squared minus 3x plus 1. Now, one thing that you guys should know is that this is a quadratic, right? Quadratic. And from a quadratic, from the complete the square method, I can find the remaining roots. Okay, so that's very important. Our first step is to find our root by trial and error, which gives us the quadratic, and from the quadratic we can use this complete the square method to find the other two roots. Okay, so let's do that. I hope you guys remember that whenever we do complete the square method, we always have to get rid of the coefficient in front of the x squared. So the way we do that is to divide everything by 2. Oh, I think I made a mistake. That should be a 6 here. That should be a 6. Okay, so let's get started. So we have, I'll write it down again. So 2x squared minus 3x plus 6. So that converts to x squared minus 3 over 2x plus 3. Okay, so when we complete the square for this part, that would be x minus 3 over 4 square plus 3 minus 9 over 16 gives me 0. Okay, so that would give us, or that will simplify to x minus 3 over 4 is equals to negative 39 over 16. So therefore x1 is equals to 3 over 4 plus or minus 39 over 16i. Okay, so what is our factors? So our factor is x plus 1, and then there will be x minus 3 over 4 minus 39 over 16i, and then x minus 3 over 4 plus 39 over 16i, like that. Okay, so these are my factors. These are my first factor. This is my first factor. My second factor. Okay, and my last factor, which is this part here. Okay, so I hope you guys have a clear image of how you solve a cubic function. Okay, again, I just want to recap something, is that the first part that you have to do is that you need to know what is the factors for d. Okay, and from the factors of D, you can deduce which value will give you uh, px gives you 0. We need to find that value. Okay, so we found that the x equals to negative 1, px is equals to 0. Okay, so x plus 1 is a factor, and you use long division. So this is the long division, long div, to get my quadratic. Okay, and from the quadratic, you use complete the square method, to find the other two roots. Okay, which is this one and this one. Okay, I'll have one special case, which is I'll just do another example of this, but in a much more complex situation. Okay, guys, hope you guys understand, and if you don't, always remember that the discussion board is for you to gain better understanding. Okay, so if you have any questions at all, please contact me on the discussion board. Okay, so I'll see you guys in the next lecture.